Okay, my next example says 2x plus 1 divided by x minus 5. 2x plus 1 divided by x minus 5 is less than or equal to 3. Less than or equal to 3. So again, the technique is very similar. We take our 3 to the left side of the equal sign, the inequality, and we have 2x plus 1 over x minus 5 minus 3 over 1 is less than or equal to 0. So we find our least common multiple again by multiplying x minus 5 times 1, and we get x minus 5. And through the last example that we just looked at, you refer back to it if I'm going a little bit too fast. X minus 5 goes into x minus 5 one time. We take the 1 and we multiply times 2x plus 1, and we get 2x plus 1. Bring down our minus sign from the problem. Now 1 goes into x minus 5 times. We take it and we multiply it times 3, which again is our classic distributive property waiting to happen. So as we get ready to rationalize in the numerator, we use our distributive property. Bring down actually my 2x plus 1. A negative 3 times x is negative 3x. Negative 3 times negative 5 is positive 15. All over x minus 5 less than or equal to 0. So as we get ready to combine like terms, as we get ready to combine like terms in the numerator, we see that we can combine 2x minus 3x, giving us negative x, and 1 plus 15 gives me a positive 16 over x minus 5 less than or equal to 0. So again, we can see now that it's really just basically a good exercise of our algebra skills that we've learned. So repetition is always key. So if we take both of these expressions and set them equal to 0, this says that negative x plus 16, and this is done so that we can find our test points. Negative x plus 16 equal to 0 says that negative x is equal to negative 16, which here it is understood as a coefficient in front of x to be a 1. So if we divide both sides by negative 1, we have that x is actually equal to 16. That is a test point. And if we set x minus 5 equal to 0, this is easy. This says that x equal to 5 is a test point. So our two test points will be 5 and 16. So we get ready to put them on the number line. We partition our number line. 5 and 16, dotted line, dotted line. My two factors are negative x plus 16 and x minus 5. So if I try to point to the left of 5, like 0, negative 0, 0 is non-negative, so 0 plus 16 is positive. 0 minus 5 is negative. If I try to point between 5 and 16 like 10, negative 10 plus 16 is a positive number, and 10 minus 5 is positive. Anything to the right of 16 like 20, we would say negative 20 plus 16 gives me a negative answer, and 20 minus 5 is positive. And again, I'm dividing, so positive divided by a negative is a negative. A positive divided by a positive is a positive. And a negative divided by a positive is a negative. And so just like one of the earlier examples, I want to consider only first those solutions that will produce those answers that are strictly less than 0. In other words, they will produce negative solutions. And we see that's happening from 5 to negative infinity and from 16 to positive infinity. So if I put both of these numbers on the real line, 5 and 16, we have an open circle, going to the left to depict that we're going to negative infinity, going to the right to depict that we're going to positive infinity. Now this picture illustrates all solutions that will produce an answer that is less than 0, but of course we want those again that will make our answer actually equal to 0. So again, as a fraction, the only type of fractions that produce answers of 0 are those in which our fraction is 0 in the numerator. So we've already done this earlier. If we take negative x plus 16, set it equal to 0 and solve it, we see that the only value of x that makes this happen is 16. So if we plug in 16 here, this negative sign causes that 16 to be negative, and so we'll have negative 16 plus 16 is 0. That lets me know that I need to shade in my 16 here, and the 5 stays open.